Hey guys, in this video we're going to solve P1 October 2025. Now this is the latest paper for P1 and it has some new ideas that you must know. Now I'm going to solve in this video from question 5 to question 10. And let's get started. So question 5 shows you a graph of a straight line intersecting with the parabola. Question A. Express 2x squared minus 16x plus 50 in the form ax plus b squared plus c. Now you have to complete the square in this question. So 2 times x minus 16 over 2 times 2 squared minus negative 16 over 2 times 2 squared plus 50. Now 16 over 4 is 4, so that's just 4. X minus 4 squared minus 4 squared, which is 16, plus 50. 2 times x minus 4 squared minus 32 plus 50. So 2x minus 4 squared plus 18, where a equals 2, b equal negative 4, c equal 18. Next question. B. Figure 1 shows a sketch of the curve C with equation y equal 2x squared minus 16x plus 50. Given that in figure 1, M is the point in C, minimum point, the line L passes through the origin and intersects C at the point M and P. Find, using algebra and showing you're working, the x coordinate of P. So that's the minimum. Clearly L passes through the origin, so it has no y-intercept. And I would highly suggest that you take it as a note that any straight line that passes through the origin, it has no c, or c equals 0, since it intersects the x-axis at the x and y-axis at y at 0. So it's just y equal mx for any straight line passing through the origin. So first of all, we need to find the equation for line L. But we need to have 2 points. So we could find the minimum point using completing the square. So we know that the minimum point is 418, because in completing the square it's negative h and k, where this is k, this is negative h, or 4. So the gradient is 18 minus 0 over 5 minus 0, since it passes through the origin. 18 over 4, which is equal to 9 over 2. Y equal 9 over 2 x. Line L1, or L, just L. I'm sorry. Then it's just easy. Y equals y. 9 over 2x equals 2x squared minus 16x plus 50. We move this to the other side. 2x squared minus 41 over 2x plus 50 equals 0. Now I would highly suggest that you're making all whole numbers. So I'm just multiply by 2. 4x squared minus 41x plus 100 equals 0. X equal, we use the quadratic formula. 41 plus minus square root of negative 41 squared minus 4 for 100 over 2 times 4. X equal 41 plus minus square root of, now I'm gonna use the calculator. 81 over 8. X equals, now 81 is a perfect square for 9, so it's just 41 plus minus 9 over 8. X equal 41 plus 9 over 8, which is equal to 50 over 8, or 25 over 4, or x equal 41 minus 9 over 8, which is 32 over 8, which is 4. And that's point M. So our point B is that. So x coordinate of P is 5 over 4. Now you can just simplify and use a calculator, but sometimes you lose marks on just simplifying. You won't lose marks if you use the quadratic formula. So I suggest that you use it all the time and just use the calculator to check the answers. Question C. The region R is shown shaded in figure 1. Use inequalities to fully define R. Okay, so that's the shaded region that he wants. So, since it's outside the parabola, it must be less than the equation of the parabola. So, y is less than or equal to 2x squared minus 16x plus 50, and it's above the linear line, so it's more than. So because as we know, under the line is less than, and above the line is more than. So y more than 9 over 2x, and here it's in the x-axis it's between 0 and m, which is 4. So you could write x is equal to 0 or 4, between 0 and 4, and y greater than 0, since it's in the positive quadrant. And let's start in that. Y less than, no, oh yeah. Now if you write just x is greater than 0, you might lose 1 mark. So just make sure to write it's also between 0 and 4. Next question. A. Sketch the graph of the curve C with equation y equal 4k over x minus 2k, where k is positive. On your sketch, show the coordinates of any point or C across the coordinate axes, the equation of the vertical asymptote to C. So that's a reciprocal function because it's x or 1 over x. And the asymptote is x must not be 2k because if it was, it would be an error because 4k over 0 is an error. So the asymptote must be x equal to k. Oh, I'm sorry. I'm so bad at drawing things. Okay, here's the line. X equal to k. Now, how did I know that the line is in the positive quadrant? Because he said k is a positive integer. So you can't put it right here. You will get it wrong. You will lose marks. Just make sure to read the question carefully. And draw the reciprocal. Now it seems here that it cuts the y-axis. So x equals 0. Y equal 4k over 0 minus 2k. Or equal 4k over negative 2k. K cancels out. So negative 2. That's 0, negative 2. And that's 4 marks. Next question. The straight line L has equation y equals 6 minus 2x. Given that there is at least one point of intersection between L and C, find the range of possible values of k. So, or wait. Given that there is at least one point of intersection, so discriminant is equal to 0. Because as we know, 2 intersections is more than 0. No intersections is less than 0. Just memorize it. Okay. B. We're just gonna make them equal. 6 minus 2x equal 4k over x minus 2k. Now just multiply this by this. 6 minus 2x times x minus 2k equal 4k. 6 times x, 6x minus 12k minus 2x squared plus 4k. No, 4kx equal 4k. So moving the 4k to the other side, 6x minus 12k minus 2x squared plus 4kx minus 4k equals 0. Now we have negative 4k and negative 2k, so we can just add them together to simplify it even more. Equals 0. Let's write it in the quadratic type. Minus 2x squared. We could take the x as a common factor between 4k and 6 plus 4k plus 6 times x minus 16k equals 0. Now we just use the discriminant to find the value of k. And we know discriminant must be equal to 0 since it's just one point of intersection. That's A, that's B, and that's C. So 4k plus 6 squared minus 4 negative 2 negative 16k equals 0. 16k squared. Now a faster type to simplify any squared brackets, it's just a squared plus 2ab plus b squared. So a squared is 16k squared plus 2 times 4k times 6, which is 4k times 6 is 24k, 48k plus 36 minus, because 3 minuses, it will just say minus. I'm gonna just use the calculator. Minus 128k. So 16k squared minus 48 minus 128 is minus 80k plus 36 equals 0. To get k, we just use quadratic formula. Of I'm just gonna skip all these tips and just write the answer. K equal 9/2 or k equals half. We are not done yet. We still have to find the range. Now, because the coefficient is positive, we could sketch a parabola. That's 9/2, and that's half. The answer is outside x, in this time it's k is greater than or equal to 9/2, or k is less than or equal to half. Since we take outside the parabola. Is that all the question? Yeah. Next question. Oh, that's circles. First thing we need to know about questions about radians and circles is just analyze the shape. So we could see that that's a minor sector, that's major sector, that's the radius, I'm just gonna write it R, of minor sector. That's thing, that dotted, and the whole line, that's radius of major sector. Measure. Given that angle POS is 1.65 radians, that's 1.65. Now we know that all of the angle must be equal to 2 pi. So if that's 1.65, that angle must be 2 pi minus 1.65, because if you add them all together, it must be 2 pi. That's the angle for minor sector, and that's the angle for major sector. The area is 30 meters. Okay. Sector POS is the minor sector, so 30. PQ is 2.8. Now, if that's 2.8, then SR must be equal to 2.8 as well, since they are the same thing. It's a circle. Question A. Show that to three significant figures, IQ is equal to 8.83. Line IQ is this whole thing, or it's just the radius for the major sector. Okay. Since we know the area and the equation for the area of a circle is half r squared theta. So 30 equal half. We don't know the r. We need to find the r plus 2.8, which is equal to the whole line. R squared times 1.65. That's the angle. So r equal to square root 30 times 2 over 1.65. I must show that square root of all of them equal 6.03. That's the radius. Now 6.03 plus 2.8, which is that small line, equal 8.83, which is as instructed. B. Find the total surface area of the swimming pool to the nearest integer. Now the total surface area is area of this minor sector plus area of major sector. We already know that the area of minor sector is 30. Now we just need to know the area of major sector and add them together. Area of major sector half. Now the radius for the major sector is 8.3, the one that we just found out, times 8.83 squared times 2 pi minus 1.65 equal 180.6. Now, total surface area is 180.6 plus 30, which is equal to 210.6 meter squared, of course, and that's meter. C. Find the total perimeter of the swimming pool in nearest meter to two significant figures. Oh, wait. In question B it says nearest integer, so it's equal to 211 meters squared. You might lose marks if you don't round it. C. Now the perimeter is arc length of this minor sector plus arc length of this major sector plus 2.8 times 2, which is this side and this side. Don't forget them. So minor sector arc length, it's, oh wait, yeah, r is 6.03 times theta, which is 1.65, equal to 9.95. Measure sector arc length, (8.83 times 2 pi minus 1.65). It's 40.91. So total perimeter is 9.95 plus 40.91 plus 2.8 times 2 equal, I'll just use the calculator, 56.46. It wants it in two significant figures, so we could assume it's 57 meters. Next question, question 8. A curve has equation y equal f of x, where x is greater than 0. Given that f prime of x is equal to 2x plus 8 over x squared plus k, or k is constant. The equation of the tangent to the curve at x equal to root of 2 is y equal to 5x minus 3 root of 2. Okay, question A. Find the exact value of k. Now we know that the gradient of at x equal root of 2 is 5, because it's just y equal mx plus c. That's c and that's m. So, and the gradient of the tangent is the differentiation of the I'm sorry. The differentiation of the curve equation. So we already have the f prime. So f prime of root of 2 must be equal to 5. So 5 equal 2 times root of 2 plus 8 over root of 2 squared, which is just 2 plus k. So k equal 5 minus 4 minus 2 root of 2, which is 1 minus 2 root of 2. That's question A. Question B. Find an equation for the normal to the curve at x equal root of 2. So we know that the gradient of the normal is the reciprocal of the gradient of the tangent. So that if you multiply them, they must be equal to -1. So the gradient of normal is equal to -1 over 5. And y equals -1 over 5x plus c. But we don't have any points or the y-intersect. So how could we find it? I think we should get back to this equation and substitute x so that it's root of 2 minus 3 root of 2 to find the value of y at x equal root of 2, which is just the point. 2 root of 2. So the point is root of 2, 2 root of 2. Or I'll just keep it. So y equal negative 1 over 5 x plus c. Now we could substitute 2 points. 2 root of 2 equal negative 1 over 5 root of 2 plus c. C equal 2 root of 2 plus root of 2 over 5. C equal 11 root of 2 over 5. And y equal negative 1 over 5x plus 11 root of 2 over 5. Now this question is a bit tricky and it's quite unfortunate that it has only 2 marks. Like it should be at least 3 to 4 marks, in my opinion. It had a lot of work. Question C. Find f of x, writing your answer in simplest form. To find f of x, we need to integrate this. So let's just use the integral. I'm writing the better way. 2x plus 8x negative 2. I'll just put k in this form and then we could substitute it so that I could write faster and easier. And time is valuable so much in the exam. So it's 2x squared over 2 plus 8x negative 1 over negative 1 plus kx plus c. So x squared minus 8x negative 1 plus k is 1 minus 2 root of 2 plus c equals y. Now if you stop here you could get like 2 to 3 marks, which is half the marks for the question. I mean it's good, but we need to get C first. Now we substitute the value of the points. 2 root of 2 equal root of 2 squared minus 8 root of 2 negative 1 negative 1 plus 1 minus 2 root of 2 times root of 2 plus c equal, I'll just use the calculator. Minus 8. So c is equal to 2 plus 5 root of 2. And now y equal x squared minus 8 over x, because it's x to the power -1, which is that times 1 over x, so minus 8 over x, plus 1 minus 2 root of 2 x plus 2 plus 5 root of 2. Next question. Figure 3 shows sketch of part of the graph of trigonometric function with the equation y equal for f of x. Write down an expression for f of x. Now the graph shows a sine wave, because the sine wave is like this. But it's reflected by the x-axis, because as you could see, if you compare them both, that's upward and that's downward in the negative. Also, you could find that that's 4, which is multiplied by 4. The normal is 1. So it's the vertical stretch by 4, and it's a reflection in the x-axis as well. So f of x, that's question A, equal -4 sine x, because the reflection in the x-axis represents negative sign. And to check your value if it's correct or not, use a calculator. Put here pi over 2, -4 times sine pi over 2. It gives you, oh never mind. Oh yeah. Wait, it's my calculator is not in radians mode. Yeah, that's a sign that you should always check if your calculator is in sine or radians. And look, it gives me a value of -4, which is, as the graph shows, B. The point B lies on y equal f of x. That's point P. Now that's 3 pi over 2, or 270 degrees. That's the point in the original graph. Say the coordinates of y equal f of x minus pi over 6. Now inside the brackets minus, which means pi 6 units to the right, not to the left. So if that's 3 pi over 2, or 9 pi over 6 plus pi over 6, which is 10 pi over 6. Bi P is 10 pi over 6, or you could simplify it and write it as 5 pi over 3, but I'm just gonna keep it. And the y value is not gonna change, since it's just the x-axis is just changed. It's just gonna stay 4. Next question. Y equal -half f of x. Now that's just a change in the y-axis, and it's a reflection and a stretch by half. So it's gonna return to its original shape like that, and it's gonna be 2 the maximum, not 4 or 1. So P is 3 pi over 2. We are not gonna change anything in the x-axis. and negative 2. Next question. Now the graph shows a cubic function, x cubed, and a linear straight line, which is y equal mx plus c, intersecting at 3 points, and that point is the y-intercept, so x is equal to 0 at this point. X equals 0. The line L1 is the normal to C at the point P, where x equals 0. So it's the normal at this point, P. Find using algebra the x-coordinate of point Q. Okay. So what we're gonna need is the coordinates of this point, P. Since we already know that its y-intercept is gonna be 0, and if you put 0 inside, we'll get a y-intercept of 5. So y equal to 0 cubed plus half 0, so 0 plus 5. It's just gonna remain 5. So point P is 0, 5. Now we're gonna have to differentiate that function to get the gradient of the tangent and then the reciprocal, which is reciprocal to tangent. So dy over dx equal 6x squared plus 2 over 2x minus 2 equal 6x squared plus x minus 2 dy over dx when x is equal to 0, which is point P. We are trying to find the gradient to the tangent at P. 6, 0 squared plus 0 minus 2 equal negative 2. Now, the tangent gradient is negative 2, so the gradient to the normal must be the reciprocal, which is half, positive half. Y equal half x plus c. Now all of that, we're just trying to find L1. We could substitute the values of y and x. 5 equal half 0 plus c. C is equal to 5. Y equal half x plus 5. That's line L. Then to find all of the points of intersection, which is Q, P, and R, we're gonna put y equals y, or f of x equal f of x. So half of x plus 5 equal 2x cubed plus half x squared plus minus 2x plus 5. Both 5's on the equations are gonna cancel. We're gonna move half of x in the other side. 0 equal to x cubed plus half x squared minus 5 over 2x. We could take x as a common factor. 0 equal x times 2x squared plus half x minus 5 over 2. Now you know what? I'm gonna multiply it by 2, all of the equation, just so that I could make it all whole numbers. Plus x minus 5. Now that's easier for me. You don't have to do that, but it's just for me. X equal. We're gonna use the quadratic formula, because as I told you, sometimes simplifying is risky and you could lose marks. Equal to negative 1 plus minus root of 1 squared 2 times 1 equal negative 1. Oh wait, 2 times 4, I'm sorry. Now 120 times 4, 80. 81? No, wait. 81. Yeah. Over 8. Now that's a perfect square, so x equal negative 1 plus minus 9 over 8. X plus 1 plus 9 over 8. 10 over 8 or 5 over 4. Oh wait, I'm sorry. It's negative 1. So 8 over 8, which is 1. That's one value for x, and the other value is negative 1 minus 9 over 8. Negative 10 over 8 or negative 5 over 4. Now if you look at the graph, we could find that x equals 0, which is that x equals 0, and the 2 points 1 and negative 5 over 4. Now that's R, that's 1, that's the point R, and negative 5 over 4 is Q, because it's in the negative gradient. So you just write your conclusion and you get the marks. Question B. The point T lies on C, given that the tangent to C at T is positive. The x coordinate of T is positive. Find using algebra the exact x coordinate of T. Now T somewhere lies here in the positive gradient. Maybe here T, we don't know. It's just in the positive gradient quadrant. And the tangent to C at T is parallel to L. So they have the same gradient, which is m equals half. Okay. So, if you know the gradient and it's a tangent, so we could just make it 6 squared. Wait, what is it? That minus 2 equals to half. Because we know that f prime of x, which x we could substitute any value on the curve, and t is one of them. They give us the gradient of the tangent. So we move half to the other side. I'm gonna multiply by 2. 12x squared plus 2x minus 5 equals 0. X equal -2 plus minus root of 2 squared minus 4 12 -5 over 2 times 12. (244 over 24). And square root of 244 is 2 root of 61 equal -2 plus minus 2 root of 61 over 24. Okay, so you could just use the calculator. Now that's the positive. 2 root of 61 over 24 or -2 minus 2 root of 61 over 24. That's equal to -1 plus root of 61 over 12, and that's equal to -1 minus root of 61 over 12. Now obviously that would be a positive. If you put it on the calculator, it's gonna be 0.567. Okay, I'm sorry. 67. That's gonna give you a negative value for x, but the question said t is positive, so we have only one value for t, which is that. So x coordinate for t is -1 plus root of 61 over 12. And that's the paper. That's it. Now I know if you find it hard, I know it's hard and it's okay. Like it was for me in the mock. I got the same paper, this one. I got 67 out of 75. It was a hard one and it had some new ideas like this one. It was my first time seeing something like this. And it's okay if you find it hard. The only good thing is that you need to learn, practice. Hope this video helps, and bye.